Alright, so guys, welcome to the lesson for today. And today we'll be talking about the testing of concrete. And yeah, this is Quincy. Welcome back. And our objectives for today is to define the process of concrete testing, list the types of concrete tests, and explain the process involved in each concrete test. Right, so here we go. So the definition. So the testing of concrete is a process whereby the properties of concrete are determined. That just means that this is where we test the concrete to see if all the properties such as durability, strength, roughness, the properties of the aggregates that make up the concrete are determined. And there are two states in which concrete exists: the fresh or plastic concrete, my mistake, or hardened concrete. And for the fresh concrete, we do a test that is known as slump test. And for the hardened concrete, we do a test that is known as compressive strength test. So slump test. So the slump test is suitable for establishing uniformity of mixes in subsequent batches or deliveries. It is not strictly a test for workability, and workability meaning how easy you can mix the concrete or how workable it is, how easy to work with, but it can be used as a guide when constituents are known to be constant. So and what that means is that you use it as a marker to help you to indicate when the different materials are constant. So we talk about the ratios. When we know that ratio, we use them as a guide. When you can use the slump test as a guide to see whether or not the mix is uniform, whether or not the mix is equally balanced and stuff like that. Mixes of the same slump can vary with regard to their cement content and grade of aggregates. So this means that the slump mixes, the concrete mixes of the same slump, mean that if you have different mixes but that produce the same slump, the reason why these different mixes can produce that same slump is because the cement content may be different or the grading of the aggregates. And when you talk about the grading of the aggregate, talk about the fine and the coarse aggregates, how they are, the different sizes, their shapes, their moisture content, and these different things. Slump test. And here are the list of equipments used in the slump test. To carry out a slump test, you need an open-end steel frustrum of a cone, a tamping rod, and a rule. A meter rule, a centimeter rule, it doesn't matter. A ruler. And here is an image showing it. So here we have the conical mold right here, and giving some dimensions 100. We have the conical mold, two handles. We have the tamping rod, and tamping rod is used to actually rod the cement, or tamp the cement means that you kind of tap it in the mix. That's what tamping means. And you have the meter rule over here, right here, and this is how you measure the slump. That after you pour the cement in, you do the tamping process. We're going to talk about the procedure after this, but you flip the cone over and you lay the tamping rod on top of it, flipped over, and where the slump is, flip the cone over beside the slump, lay the tamping rod up on top of the slump, and you measure the difference that's this little space right here between the slump and the height of the tamping, the height of the cone where the tamping rod is on. And there you get the difference, and you get the how far the cement would have slumped down. So here are the procedure. The cone, that is the conical mold, is 1/4 filled with concrete. The concrete is stamped 25 times. Not 10, not 15, not 20, but 25 times. And a further 3 layers are applied, each layer tamped as described. So the cone filled 1/4, and they tamp it 25 times after they fill it. They put in another quarter, you tamp it 25 times. Put in another quarter, you tamp it 25 times. You put in that last quarter, which would have carried it to the top, and you tamp it 25 times. That's what the further 3 layers stand for. And it says surplus concrete is struck off from the top and the cone is raised immediately. And what that means is that any excess at the top of the cone, they just kind of just remove it from the top, or scrape it off for one, for understanding purposes. And here we have a video, 3-minute video, 4-minute video.
The ease with which one can work with concrete is called workability. This can be measured using a simple test called the slump test. Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel tamping rod of 16 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth, horizontal, rigid and non-absorbent surface. It is then filled in 4 layers with the thickness of each layer being approximately 1/4 of the height of the mold. Each layer should be tamped 25 times evenly using the rounded end of the tamping rod such that strokes are uniformly distributed over the cross section. After the top layer is tamped, the concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibrations and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may either be a true slump, a shear slump, or a collapsible slump. The true slump is the desired form of slump that we require. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapsed slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a shear or collapsed slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can also be varied by changing the proportion, size, and combination of the various sizes of the aggregates. It is advisable to assess the workability of concrete mix using a slump cone. Ensure that the cone is filled in a proper manner as indicated. Notice the type of slump. Shear and collapse slump are undesirable. Adjust the slump to the desired value by changing the proportion.
And there you had a video just showing you the procedure involving the slump test. So now we're moving on to the compressive strength test or the compression test. So this test is done to test the load bearing strength of the concrete. So the load bearing strength of the concrete is used to test when this test is done. And the term compression refers to the pushing or pressing forces And this would be the pushing and pressing forces applying to concrete. It says that concrete test cubes are made from samples taken from site, and specimens are taken before and during the placing of concrete. So they use cubes of concrete taken from mixes that would have been done on site. So the mixes of concrete would have, the cubes would have the same mix ratio as the one on site. And as a result, they test these. And here we have the equipment, a standard machine mold of 150 millimeter by 150 millimeter by 150 millimeter. That's volume. For aggregate size is up to 40 millimeters. 100 millimeter cube molds may be used for aggregates up to 20 millimeter. So they have the smaller standards for the one there. The internal faces of the mold are lightly oiled prior to receiving the concrete. This is to ensure that the concrete doesn't harden to the mold itself and sticks. It says that other equipment, a 25 millimeter square steel tamping rod that is 380 millimeter long. And here we have an image of that one. So here you have the 25 millimeter square tamping rod. You have the mold, the steel mold, steel test cube mold. You have the steel plate base. Other two equipments used are the steel plate base, which where the mold sits on. That's this one down here. And you have the pressure gauge, which is this thing right here that shows the amount of pressure being applied. And it can be analog. It looks like a clock, like a scale. Analog that has the numbers and you have to read them, or it can be digital that shows you the amount of pressure being applied. Most modern ones are digital. So you have the tamping rod, the mold, the steel test cube mold, the steel plate base, and the pressure gauge. And it shows an illustration of what happens when the pressure when the test is occurring, the sample before the test, sample after stress failure, which means that the concrete has broken, to show how much pressure is applied before the concrete fails. And here's the procedure. Concrete is placed in a mold in 50 millimeter layers. So 50 millimeter layers they place the concrete in. So the last time we placed them in a quarter of the mold size. Now we just 50 millimeter layers. Each layer is stamped 35 times for 150 millimeter cubes and 25 times for 100 millimeter cubes. Alternatively, the concrete may be compacted by vibration. So what that last part, the alternative part, is saying that the tamping is done to ensure that there is no settling is to ensure that the concrete, the mixture is thoroughly mixed out or is consistent throughout in the mold. And this can also be done by vibration. So you can use a vibrator to ensure that this happens. The surplus concrete is struck off. So since if you have a 150 millimeter cube, you're gonna have 3 layers that you tamp. It's a tamp 3 times. If it's a 100 millimeter cube, you have 2 layers that you tamp 2 times, 2 sets of times, 25 times. You strike off the surplus, just similar to the slump test, and the samples will remain in the mold for 24 hours, covered with a damp sack or similar. So this is all when the concrete is fresh, and it stays in the mold for 24 hours plus or minus 30 minutes to ensure that it dries. So this is to ensure that the concrete dries and hardens. After this time, specimens are marked. After the 24-hour period, you mark it and remove it from the mold. Now this is where you take away the mold and you have the concrete cube itself. When you have the concrete cube itself now, it says that you submerge in water at a temperature between 10 and 21 degrees Celsius. And that is below room temperature. So you submerge it in water, meaning they put it completely in water until ready for testing. And you have different type day lengths when you want to test concrete. You have 3-day tests, you have 7-day tests, you have 28-day tests, you have 14-day tests. So these are different days. The cube strength is a stress failure after 7 days. If the strength specification is not achieved at 7 days, a further test is undertaken at 28 days. So the 7 days after should give you the cube strength. After the stress failure at 7 days, that's how you find the cube strength. And if the strength that you're looking for is not, if you don't gain that after 7 days, it says a further test should be done at 28 days. It says if the specification is not achieved at 28 days, the specimen cores may be taken from the placed concrete for a lab analysis. So what this means is that if at 7 days you get the cube strength after you do the test after 7 days, after you make it soak in the water for 7 days, you test the strength by applying the pressure, putting it in the machine that it applies the load to apply the pressure. And the strength of the cube would be determined from that. If the strength that you want is not what you get by the machine, so if you look on the gauge or look on the digital screen, I tell you that the strength is not what you're looking for, you do another 28-day test. So you'd have another cube that would stay in the water for 28 days. And you take it out and you test that strength. If that same strength, if the strength that you get after 28 days is not the one that you want, then you'd have to take back that concrete now for analysis to the lab. A typical 28-day characteristic crushing strength, that below which no more than 5% of the test results are allowed to fall, are graded at 7.5, 10, 15, 20, 25, 30, 35, and 40 newtons per millimeter square. Here we have the procedure in a short video.
Compressive strength of the concrete is to be assessed properly since it is an important parameter linked with strength and durability. Let us see how the concrete cube is tested. Compressive strength of concrete after 28 days of casting is a very important measurement to assess the quality of concrete. The concrete cubes are cast, cured for 28 days and tested on a compression testing machine. Before testing, the dimensions of the cubes are checked and their weights are noted. The load applying plates, called platons of the testing machines, should be wiped clean. Loose sand or other materials should be removed from the surface of the specimen which is in contact with the platons of the compression testing machine. The cube should be placed in the machine so that the top surface of the cube as cast is facing sideways. The cube shall be placed centrally between the platons. It should be ensured that uniform seating is obtained. The load should be applied without shock and increased continuously at a rate of approximately 140 kilograms per square centimeter per minute until the specimen breaks and no further load can be sustained. The maximum load applied to the specimen shall then be recorded. The strength is calculated by dividing the load on the cube at failure by the cross-sectional area. Care should be taken while testing cubes for strength. Dimensions and weight of the cube are checked before testing. Ensure that testing machine is in good condition and cube is placed properly. Load should be applied at a rate of about 140 kilograms per square centimeter per minute.
So there you just saw that video on compression test procedure, and this is where we got the notes from for this presentation. So you can get the book, do some additional reading, and you guys should be good for the test. So enjoy the rest of your day and look out for the next video coming out. Alright class, all the best.